Before we begin, what is a free body diagram? Free body diagrams are simplified diagrams to show the magnitude and direction of forces acting on an object. They involve the use of simple boxes and arrows. Plus, the direction of the arrows shows the direction of the forces acting on the object. On the other hand, a vector resolution is the process of deciding the magnitude of a vector. Basically, it's the arrows on a free body diagram. Now let's look at how to make a free body diagram. We'll refer to our class notes and use the example given in class, which was a person pushing on a cart 5 newtons to the right and the cart moving at 15 newtons to the right. We'll look at how to make a free body diagram and calculate the net force, or the resulting force. The first step is really simple, because all you have to do is turn that object into a box. The next step is to add in the force vectors. In this example, we already added the 5 newtons of the person pushing the cart, and then we add in the 15 newtons of the cart actually moving. Don't forget to make sure that all your force vectors are within scale of each other. The third step is to calculate the FR, or the net force, basically the resulting force. This example is very simple because both forces are going the same direction, which means we just have to add a simple addition of 5 plus 15, which would equal 20 newtons to the right. Now let's look at a different example from Mr. Anderson. As you can see, there's a bottle of wine that's just on a table. So if we want to draw a free body diagram, we have to first convert that wine into a simple box. After that, we add in the force vectors. Now, since it's not moving, there's only two. The force vector for gravity, and then normal force, which is going in the opposite direction. This is because of Newton's third law, which states that for every action, in this case gravity, there is an equal reaction going in the opposite direction, which is normal force. This is why the bottle of wine is perfectly still. Now let's try making a free body diagram based on the clip of Unstoppable that we saw in class.
1206, this is Connie Hooper, are you there?
1206, over.
Just wanted to see how you boys are doing.
We're doing about 60 miles an hour, Connie.
Sorry? Frank, I don't understand.
We're going after your train.
1206, I'm not hearing you.
The rear knuckle was left open, so if we can catch up, we can tie it on to our locomotive. Try and slow down 777.
Frank, you can't.
We already are.
That train's carrying 30,000 gallons of toxic chemicals. They had a window before, but that train's going into populated areas. There's no way they derail it now.
Are you sure about that?
So let's start with our first step, which is converting the 1206 train into a simple box. When we're done with doing that, we add in the force vectors, the first being the train moving 60 miles per hour. And then we add a force vector to the top and the bottom for gravity, and then the one on top for normal force. And then we add another force vector for friction going opposite of the 60 miles per hour because friction decelerates an object. And this concludes our video. Thank you for watching.